Hello students, welcome to the channel Statistica Hub. So in this particular video, we are going to start with our GATE statistics paper. So in this video, I will take up the first problem. Like technically, we are going to start with the statistical part and the mathematical part. We are not going for the initial 10 problems. In this playlist, there will be a separate playlist for that one. Okay, so this is like your problem number 11 in the paper 2024. So let's try to understand what is given in the problem, then we will move to the solution. Okay, so let's understand the problem that you are given, that we are having the setup that we have to find some sort of like integration over some region. So we are given that we have to solve this integration over some region D, x, dx, dy. That's what we have to find. Now, the region D that will be calculated using the equations that are given in the problem. Okay, so we are given the equation y that equal to x and the other equation that is y that is 4x minus x square. So that's what we are having. So if somebody want to see like what will be this particular area that will be bounded in these two things, so you can simply see this is the equation of a parabola. Okay, and this is the equation of a line. So without constructing anything, if I give the basic idea, so I can see there is a negative term. So that will be a parabola that will be like open on the downside. So we are going to have the structure that will look like this. This is the x, this will be your y. And without calculating the roots or something, let's say the parabola is coming out to be something like this. That's what we are having. And if you go for the line, then the line will be simply y equal to x. So that will be your line. Okay, so this will be the area that we are interested in. So over this region, we have to calculate this particular integration, that is the double integration. Okay, let's move to this part. So to calculate this integration, first you have to get the cutoff points on which the curve and the parabola, they are hitting each other or cutting each other or intersecting each other. Okay, so let's try to find those particular points. So we can put up the x that will be equal to 4x minus x square. So I will be getting simply the x square minus 3x that is coming out to be 0. And you can simply see we are going to have the roots that will be x minus 3, that is 0. So we got the point of intersection. So the point of intersection in this problem that is coming out to be at x equal to 0 and at x equal to 3. So these are the two intersection points. Okay, so now we got what will be the D region. So I can simply write that the region D that will be formed by the lines. There will be different lines, the equation of these lines technically. So that will be formed by like x equal to 0, the first root, that will be x equal to 3, the second root. Moving ahead, that will be the line y equal to x, and finally the line or the curve y equal to 4x minus x square. This is the region D that will be formed by all of these lines. Like x equal to 0, that is this line, x equal to 3, that will be this line. So that's the idea. Okay, now we have to set up the double integration and we have to calculate that thing. So we have to go for the integration over D for x dx dy. So let's do that part. So in that part, I will be going for the, like the integration. Now you can keep up the limits. So we have x dx, or I can go for the change in order. So that will be like from x to, it will be going to the curve that is 4x minus x square. So 4x minus x square, and the x is having limit from 0 to 3. So that will be simply 0 to 3. So if you solve this one, you will get the final answer. So solve it. Okay. In case you want to see it further, then I'm going to solve, but till now, that is the solution and you can follow the solution. If you want to go for like self-study or something like that, that will be enough. If you want to see the proper solution, then we can go for the integration part also, though that is not required. I feel that the student must go for the proper integration in these type of problems so that you can get an idea how the things are being done. Okay, moving ahead, if I go for the integration, so we had the integration to be like this. Okay, let me write at this place only. So I will be going for the integration. We have to go for the y. So integration 0 to 3. Then we have x, y, but y is having some limits, x, and 4x minus x square. We are having dx. Okay, moving ahead with this part, you can put up the limits. So that will be coming out to be integration 0 to 3. We have x, then we have 4x minus x square minus one more x, the lower limit, and we have the dx. Okay, this is what we have to solve. So if you solve it, then it will be coming out to be integration 0 to 3. We have x, then we have 4x minus x square minus x and dx. Okay, solving it further. So I will be getting integration 0 to 3. We have x. Then if you solve this part, that will be coming out to be 3x minus x square dx. Okay, simple thing. Moving ahead with this part. Now again, you have to go for the integration, but before that one, I can just go for the multiplication first. So 0 to 3, 3x square minus x cube, and we have the dx. Okay, integrate it further. So I will be going for x cube over 3. So that will be x3 minus x4 over 4. 0 to 3 are the limits. Now you can put up the limit. So if I put up the lower limit, that will not make any difference because that is the 0 only. So we have 3 raised to the power 3 minus 3 raised to the power 4 over 4. If you solve it, you are going to get 27 minus 81 over 4. And that will be coming out to be like what we can see, that is coming out to like 27 into 4 minus 81. So roughly that is 27 over 4. So that is the final answer. Okay, I hope you are able to understand this problem. This was a straightforward problem. Just you have to go for finding up the D, then you can get the solution. So the correct answer for this one, that will be the option A, 27 over 4. Okay, easy problem, no doubt in this one. Okay, moving ahead, moving to the second problem that we have. So we have the problem number 12 over here. Okay, now this is a problem from the real analysis part. So you have to understand the problem first, because the real analysis is something that it is not so easy. Like for most of the students, they face some kind of issue in the real analysis part. Okay, so let's understand the problem first. So we are given let an that be a sequence of real numbers such that the a1 is under root of 6 and an plus 1 that is under root of 6 plus an. Okay, so whatever is given, I'm going to write that one first. So we are having some sequence n greater than equal to 1 with some condition that your a1, the first term, that will be under root of 6, and an plus 1 that is coming out to be under root of 6 plus an for all the values of n greater than equal to 1. Okay, now we are given two statements. So the first statement is saying that the sequence n greater than equal to 1 is increasing sequence. Okay, so how can we analyze this part? Is the sequence increasing or not? So how do we check that thing? So roughly I can just go for a basic solution. So we can simply assume that, you can just start with the assumption. So we assume that an is greater than 2. Okay, I'm assuming this thing. So in this setup, what is going to happen? So under this assumption, if you solve it further, so you can see an plus 1 that is given to be under root of 6 plus an. Okay, now in this particular setup, this thing is given. Just say that an is coming out to be some x. So I can say that since this under root of 6 plus x is an increasing function of, it's an increasing function of x. For what x? If the x is greater than equal to minus 6, and if an is greater than 2, not 0 but 2, then this is going to happen. So then we can just simply say, if this is under the condition, then you can simply say that under root of 6 plus an that is coming out to be greater than under root of 6 plus 2. Okay, so we can simply see this particular term that is coming out to be 6 plus an that is coming out to be greater than under root of 8, and that is greater than 2. Okay, and initially we were given something. We were given the first term that a1 that is under root of 6. We can utilize that information. So you can simply say we are given that a1 that is under root of 6. If you solve it, that is roughly coming out to be 2.45. Okay, and this number is coming out to be like greater than 2. That makes sense? Okay. Now, as we assume something that an is greater than 2, and given that under root of 6 plus an that is coming out to be greater than an, we can simply conclude that the sequence an is increasing in nature. Okay, so that was the first problem that we can solve. Now, like without solving also, you can just prove this one, because you can simply see the first term that is given to be, that is your under root of 6. That is a positive number, right? Like without solving it, you can say this thing, a1 that is under root of 6. The very next term that is coming out to be under root of 6 plus an, the previous term. So as the previous term that is increasing, so eventually the an plus 1, that is some term that will be increasing in nature. Like from the previous term, the an plus 1 that will be greater than the an, because that's how the things are defined. So in this setup, we are getting the statement A that is correct. Okay. Now we have to go for the statement number B. So how to go for the statement number B? So we are given that limit an that is coming out to be 2. So let's see that part. So in the part B, we have to check for limit n tending to infinity an that is coming out to be 2. Was that given 2? But yeah, it is given to be 2. So like without solving also, you can simply see that it will not be coming out to be 2. But if we have to prove it, you can prove this one also. So let's say the limit is coming. You have to prove this thing, right? So we assume that the limit is coming out to be something that is different from 2. So or maybe it can be anything. Let the limiting case of n tending to infinity, the anth term that is coming out to be some L. Okay. Now, you can simply write that the limit that is coming out to be under root of 6 plus L, like in the increasing order, because an plus 1, that will also be 1, and the an that is already the 1. Okay, so we can just write this thing. Now, if you just square both the sides, I will be getting the L square that is coming out to be 6 plus L. You solve it, so you are going to get L square minus L minus 6, that is coming out to be 0. Now, if you find the values, the roots that will be coming out to be L equal to 3 and L equal to minus 2. Okay, so we can simply see as the sequence that we are taking up, that is a sequence of positive terms. So the limiting case or the limiting value will be a positive number, because the first term was a positive number, and the sequence that we are dealing with, that is also a positive number. That is like in the increasing order, so it can't be negative. Okay, so we can simply say that the limit n tending to infinity of the sequence, let's say an, that is coming out to be 3. So the sequence is 3, the limiting case, but it is not equal to 2. So what we got? So we are getting only the statement 1 that is correct. So this was the second problem in your GATE statistics paper 2024. So that was all in this particular video. Stay tuned to learn more. Thank you.